This is another episode in my GCSE revision series. This particular episode will be on coordinate geometry, so straight lines, tangents, perpendiculars, that sort of thing. It's really useful for you to be watching if you've already done your revision in the background and you just want some extra hints and tips about how to address exam questions. So it's on exam questions primarily. If you want to see these topics from scratch, you can do so just by watching any other YouTube videos. There's plenty out there. But this is primarily for those of you that have just done a little bit of revision and would like to go through some exam questions with me. So yeah, if you're watching this on YouTube, it'd be really great if you could subscribe or click that like button. If you're watching this on Twitch, it'd be amazing if you could leave some comments in the chat box, which is next to where you see it on Twitch. It's just a question of you working your way through and seeing where you get to for today. Also, you can leave comments in the comments section below. I think I've already said that, but if I haven't, then please do so. Right, here we are then. We're looking at these questions here. All of them building up in difficulty as we go through, and primarily just talking about straight lines and so on. This first question talking about equations of a straight line that is parallel to this particular line, y equals 5x plus 6. So, of course, we know that the equation of a straight line is y equals mx plus c. The gradient here is 5. So any line that had the gradient of 5 will work. So if you just set that as anything with 5 as the gradient, 5x plus 21, 5x plus anything will work because it will have the same gradient. What they're looking for is the same gradient in there. It's only worth 1 mark, but anything with 5x will be fine. This second part is looking at perpendiculars. So again, the gradient is 5. The perpendicular will be minus a fifth then, because obviously you flick it upside down, put a minus in front of it. We know that lines that are perpendicular to each other, their gradients multiply to make minus 1. So in general, the equation will be y equals minus a fifth x plus c. It'd be great to work out my plus c. I do that by throwing in the values minus 2 for x, so I'll throw that in there, and then 5 in for y, so I'll throw that in there, and I'll work out what my c is. Again, if you want some more in-depth looks at this sort of stuff, then do go ahead and take a look at my Tangents to Circles YouTube video, which I did a while ago. That's a really good revision if you're doing those harder questions towards the end of the exam papers, and will give you a lot of important information that you need. And I'm doing a lot of this stuff in there as well. When you work out what C is, again, I'm going to try and not to touch a calculator so much, so you can see me working my way through this. I'm trying to not touch a calculator as much as I can, because it will be helpful if I can start to learn how to do this stuff without a calculator. So you will get 23 over 5 when you do it. So 25 minus 2 over 5, I'm just doing two fractions here, finding a common denominator and so on. So I can see the equation of the tangent is going to be a minus a fifth x plus 23 over 5. They might ask it for it in an alternative form, so you can multiply everything by 5 just to get it in a slightly different form. Sometimes they ask for it in a form where you've got something x and then the number at the end. So I've just written that alternatively here, so just to show you how that would look. So you can multiply everything by 5 just to get it looking a bit nicer. So depends on the question. This question doesn't ask for that, but sometimes they do ask for questions in the form something y plus something x equals a number. So just to show you an alternative way of looking at this particular solution, you can do it a variety of different ways. Okay, on to question 2. So here we are. This is a parallelogram, rhombus, and it's asking for telling you some things about it. So these coordinates here, 5, 11. I always write these in. I don't know why they don't write them in for you. I guess that's because they just want you to find it out for yourself. But we're going to write 5, 11 in there. The equation of this we're given in the question is a half x plus 6. So that's what they're saying this straight line is. Not very straight, sorry about that, I need a ruler. But it's asking to find the equation of the diagonals, so going from there to there. So the first thing to do is to recognise that when you have diagonals on a rhombus, you should recognise that they're at 90 degrees. So that's important to recognise straight away. So we're going to do the inverse of a half, or the minus inverse of a half. So the gradient of the tangent will be y equals minus 2x plus c. And again, to work out my plus c, I'm going to put in y is 11 and x is 5, so to work out what that is. So that will be very quick to do that, and you'll get 21 is C. So that will give me the equation of the straight line minus 2x plus 21. Not a problem at all. Question 3 coming through, the same again, similar systems, no diagram again, it's interesting. So straight line goes through both A and B. In the line with equation 2y, is the line equation 2y equals 3x minus 4 perpendicular to that line? That's what they're asking. So you first of all would need to work out a gradient, so let's do that real quick. So gradient of the line AB, so it's change in y over change in x. So minus 1 minus 3, so change in y, and then over 4 minus 1, important to get the right coordinates and not mix them up. So minus 1 minus 3 is minus 4, 4 minus 1 is 3, so it's minus 4/3 is the gradient there. This gradient here, well, the gradient of any line perpendicular to it, so gradient perpendicular will be 3/4, because obviously it's the, you flip upside down and put minus in front of it, or these two multiplied give minus 1. And so we're looking for this one. Is this going to be gradient 3/4? I can see it isn't, but we just need to show that. So 2y equals 3x minus 4. In y equals mx plus c form, this is 3 over 2x minus 2. And this does not match with this, so it is not perpendicular, because it would have to be the same. And it's not. So it's not perpendicular. So I'm happy with that. Say I've done that. Question 4. This one here is slightly more sort of strung out. So it's talking about, again, 2 points. M is the midpoint. Equation of a line. Points. So again, lots of stuff going on. Find an equation of a line that's perpendicular. So again, let's find the gradient is 2 here. So the gradient of perpendicular will be minus 1 over 2 minus a half. So the line that's going to be perpendicular to it will be minus a half x plus c. We need to use a point to get my c. The point we use is this midpoint here. The midpoint somewhere between A and B will be my midpoint. I'd like to find out where the midpoint is. The midpoint is halfway between A and B. So on the x side, it's half as much as the x change. So you can see the x change from 2 to 4 is 2 along. So if you think about what that's going to be, it's so 2 along here. So half of that change will be 1. So 1 along. So 2 plus 4 is 6. 6 divided by 2 is 3. So that's going to be the coordinate 3. And then half of the change up. And the change up is 4. So it's going to go up 2 from there. So it's going to be 9 plus 4, 5 is 14. 14 divided by 2 is 7. So 3, 7 is this point here. Once you've got the point, you can feed it into y being 7 and x being 3 to work out what c is. And again, I'm going to try not to touch a calculator yet. So I'm going to try and take my time with this one a little bit. So I think that's going to be 17 over 2. Okay, so again, the equation of the straight line that passes through M is going to be minus a half x plus 17 over 2. Again, not terribly nice. You could multiply out to get a slightly nicer form, and again, you could write it in a form that's something y. So I'm just going to show you that, something y plus something x equals a number, and sometimes the question will ask for that. So just showing that you can rearrange that differently. But yeah, in terms of questions, it's not as difficult as some of the questions that you'll encounter regarding tangents and circles and so on. It's really quite straightforward. This one, equation line passes through C is perpendicular. Again, perpendicular. The minute you mention perpendicular, you're thinking gradients. So let's work out the gradient of AB. So gradient of AB, change in y over change in x. So it's 4 up and 2 along. So it's 4 over 2. That's 2. You can see it's a positive gradient. And so the gradient of the perpendicular will be flip it upside down and put a minus in front of it. So it's minus a half. So minus a half there. And then all the way through, you've got to show then that we're finding the equation of the line. So y equals minus a half x plus c. I need to find the plus c, but you need a point, and it says it's going through c. So we need to put that point in. Y is minus 1. X is 5, and we can find out what c is. So if we do that again real quick, try not to use the calculator again. Just taking my time. So it's minus 2 first, so 3 over 2. So the equation of the straight line will be 3 over 2. So it's that, isn't it? Minus a half x plus 3 over 2. And again, you could multiply by 2, make it look a bit nicer, but that's okay. You don't have to go too much further than that. And then one last question on this. Okay, so you've got 3 points. It's saying they're all lying on a straight line. The coordinates of A and B all given to you, but it's asking you to work out the value of Q. So the strategy here, if you get this, is very similar to strategy you see in some vector questions. So again, if you want to check out my video on vectors, that gives you some of the strategy you might use for this. So the strategy here is to, if understanding they're parallel, the gradient between here and here, between A and B, is the same as the gradient between B and C, or A and C for that matter. So the thing to do is to work out the gradient between A and B, and then get a number, and whatever number that is, it's going to be replicated between B and C again. There's going to be lots of calculations to do here. So I'm going to work out the gradient of AB. So again, changing Y over changing X. So I'm going to do 0 take away 4, the change in Y. Okay, I know I'm going a bit backwards, but you hopefully understand. As long as you get it right way, you won't go wrong. So minus 4 over 9 minus 2. That's the gradient between there and there. And then again, you want to do minus 2 between there and there. So we've got to do gradient of BC will have to be the same thing. So change in Y is Q minus 4. Change in X will be 1 minus 7. So Q minus 4 over minus 6. You've got to be careful with your signs. So 1 minus Q minus 4 over minus 6 is minus 2. 6 2s are 12, so Q minus 4 equals 12. 2 minuses make a plus, remember. So 2 minuses make a plus, so you've got then Q equals 16. So that's going to be 16. So it's 1 comma 16 is the point that you're looking for. Okay, that's the final question we're going to do on this particular exercise. Bit of a shorter video. It was all about coordinate geometry, tangents, perpendiculars, that sort of thing. I would encourage you to check out some of my other videos which are available on the Maths Jedi channel. Do take a look at those. They'll really help your revision if you're working towards your summer exams. Good luck for now. I hope you have a really nice rest of the week.